In this video, we are going to discuss some important points about this curve of the CMOS inverter that we found in the previous video. And the first point that we are going to find here from the definitions, from the 6 important definitions that we defined previously, is VOH. VOH is defined as the highest output voltage. And as we see here, the highest output voltage will be VDD, the same voltage of the supply. The VOH is the highest output voltage, and at the same time it is the highest input voltage. So the highest input voltage here will be also VOH. So VOH, which is VDD, is the highest output voltage and the highest input voltage. And then comes VOL, the lowest output voltage, which is at the same time the lowest input voltage. The lowest output voltage here will be 0. So the VOL is defined to be 0. So VOH is VDD, VOL is 0. And also the lowest input voltage will be VOL, which is 0. So the lowest input and the lowest output, both of them are 0. And then it's interesting to find the point VTH. The point VTH, in order to find it, we need to ask ourselves what happens at this point. So at the point VTH, when V input equals VTH, you will find that both transistors are in saturation. And since we know that the current of both transistors is the same, so what we can do is we can equate the current of the NMOS in saturation to the current of the PMOS in saturation, and then we find what is the value of V input that makes this relation happens. So for example, let's do it. I will do this. I know there are a lot of math here. I will do some of them and I will leave the rest to you as home assignments. Okay, so for example, I will do this one. To find VTH, we will equate the current of the NMOS in saturation to the current of the PMOS in saturation. We write the equation. We find that the current of the NMOS in saturation is Kn over 2 VGS minus V threshold squared. And the current of the PMOS in saturation is Kp over 2 VSG of the PMOS minus VTP all squared. By the way, you will find in the textbook and in the slides, sometimes they write minus VTP as magnitude VTP. Don't worry, it's the same. Why is the same? Because VTP is negative. So if you take negative VTP or magnitude VTP, both of them, they will give you the positive magnitude of VTP. Okay, so whether you find negative VTP or magnitude VTP, it's the same. Here, let's cancel the 2 with the 2 and divide over Kp, so we will get Kn over Kp, VGS minus VTN squared equals VSG minus magnitude VTP squared. And now VGS is what? VGS of the NMOS is Vm, right? This is Vm. And what is? So let's replace VGS of the NMOS by Vm. And VSG of the PMOS is VDD minus Vm. So we can replace VSG here by VDD minus Vm. And then let's take square root of both sides. So if we take square roots, we'll get Kn over Kp, and here we'll have Vm minus Vtn. The other side, we have VDD minus VTP minus V input. Let's now collect the terms that contain V input together. Why? Because this is what we want. We need to find what is V input that satisfies this relation. V input that satisfies this relation is VTH, actually. So V input that satisfies this relation is VTH. So let's collect this together in one side. So what we'll have VTH multiplied by 1 plus square root Kn over Kp equals VDD minus magnitude VTP. And then we'll take this term to the other side, square root multiplied by Vtn. It will be plus square root Kn over Kp multiplied by Vtn And then if you want to find VTH now, you divide over this. So it will be VDD minus VTP magnitude plus square root Kn over Kp VTN divided by this factor, which is 1 plus square root Kn over Kp. This is now the expression of this point, the value of the input that satisfies that both transistors are working in saturation. Under a special case where both transistors are identical, which means that Kp equals Kn and Vtn equals minus magnitude minus Vtp, or in other words, it is equal to magnitude Vtp. Under this special case, we say here that the two transistors are identical because they have the same parameters exactly, okay? Then square root Kn over Kp will be 1, right? And Vtn minus Vtp will cancel together, and in this case, under this special case, Vth will be Vdd over 2, which means that it will be exactly in the middle of the curve. It will be exactly in the middle of the curve. So this is the point Vth. Another interesting points from the definitions that we defined before are the noise margins. We need to calculate the noise margin, noise margin low and noise margin high. But in order to calculate the noise margin low and noise margin high, we need to calculate VIL and VIH. And where is VIL and VIH on the curve? We defined VIL So we defined VIL to be the point at which the slope of the curve is -1. So this is the point at which the slope is -1. This is VIL. And we defined VIH to be the point at which the slope of this curve is -1. This is VIH. Once we find VIL and VIH, we can calculate the noise margin low to be VIL minus VOL, which is here, because VOL is 0 here, it will be VIL. And we can calculate the noise margin high to be VOH minus VIH, and because VOH here is VDD, it will be VDD minus VIH. But how, again, to calculate VIL and VIH, we have to find the point at which the slope is -1. How to find this point? There is a procedure that you will find in the slides, in the PowerPoint posted on the guideboard. I'm going to give you a quick idea about this procedure here, and I will leave it to you as a home assignment that you can do and submit within 1 week after you watch this video. So the procedure, for example, for finding VIH, let's take VIH as an example here, is that first you have to write the equation of this curve. And how to write the equation of this curve? You ask yourself, what happens at this curve? At this curve, the NMOS is triode and the PMOS is saturation, and both of them, they have the same current. So what you can do is, you can write the equation of the current of the NMOS in triode equals the current of the PMOS in saturation, right? Because the NMOS is in triode, PMOS is saturation, both of them, they have the same current. So you can start by writing that the current equals the current. You will get a relation from here. Of course, when you write the current equals the current, then you replace VGS by V input, VGS by V output, VSG here by VDD minus V input, VSD by VDD minus V output. So you will get an equation in V input, V output, and some constants. So you will get an equation in V input, V output, and some constants. The next step is you will differentiate the whole equation with respect to V input. The whole equation, all terms in the equation differentiate with respect to V input. You will find that some terms will be dV output by dV input. You replace dV output by dV input by -1. So you will get another equation. When you, again, you write the current equals the current, it will be in terms of V input, V output, and some constant. Differentiate all the terms with respect to V input. Differentiate the whole equation with respect to V input. Whenever you see dV output by dV input, replace it with -1, because this is the point. We are looking for the point at which the slope is -1. And in this case, V input will be V input high, right? Because at the point at which the slope is -1, V input is V input high, right? So you replace every V input with V input high, and you replace dV output by dV input by -1. You will get another equation between V input and V output and V input high. You will find that the equation is, you will get an equation V output equals V input high minus VDD over 2. So once you do that, you will get a relation between V output and V input high. You take this relation and you substitute in the original equation. Take this relation and substitute in the original equation. Substitute in I NMOS triode equals I PMOS saturation, and you will be able to reach to the final equation of VIH. VIH will be 1/8 5 VDD minus 2V threshold. You will find that VIH will be of this value. This is the procedure. You write first the equation, you differentiate with respect to V input, substitute dV output by dV input as -1 and V input by VIH. This is the point that we are looking for. You will get a relation between V output and VIH. Substitute this relation again in the current equation, you get the expression of VIH. Don't worry about a lot of math. You will do it one time as a class assignment or a homework, and you submit it, and don't worry about it later. You can do the same procedure or a similar procedure for VIL, and you will find that VIL is 1/8 3 VDD minus actually it's minus 2 V threshold. This is 2 V threshold. And once you calculate VIL and VIH, you can substitute and calculate the noise margins. The noise margin high will be equal to the noise margin low, and both of them are equal to VIL So now we calculated VIL, VIH, and the two noise margins. Okay. Two other interesting points are this point and this point. And if you want to calculate what is the value of this point and this point, I'm teaching you the procedure of how to calculate any point on the curve that you are interested to. The procedure to calculate this point or this point is ask yourself, what happens at this point and what happens at this point. Let's take one of them as an example. For example, this point. What happens at this point? At this point, the NMOS here was saturation, and here it will become triode. So at this point, the NMOS will switch from being saturation to triode. So this is the edge of saturation. This point is the edge of saturation of the NMOS. Edge of saturation means what? It's the point exactly between the triode and the saturation. We call it the edge of saturation. It's the point on the edge, exactly, on the border. At this point, what happens when the transistor is exactly at the edge of saturation? We know that the condition for saturation, VGS must be greater than VGS minus V threshold. For triode, VDS is less than VGS minus V threshold. At the edge, it is exactly equal. VDS equals VGS minus V threshold, right? So at the edge of saturation exactly of the NMOS, VDS will be equal to VGS minus V threshold. But VDS is what? V output. VGS is V input minus V threshold. So here, V output equals V input minus V threshold. But what is V input at this point? V input at this point is we just calculated, which is VTH, right? It's VDD over 2. So here it will be VDD over 2 minus V threshold. So here at the edge of saturation, it will be VDD over 2 minus V threshold. So we calculated now this point. We can do the same for this point. At this point, the PMOS here is saturation, the PMOS here is triode. So this is the edge of saturation. This is the edge of saturation. Of the PMOS. You can write the condition of the edge of saturation similar to what we did there of the PMOS, and you will find that this point will be VDD over 2 plus magnitude VTP plus magnitude VTP. So we found this point by the edge of saturation of the PMOS. We found this point by the edge of saturation of the NMOS. We can find VIL and VIH using the procedure of differentiation and setting dV output by dV input as -1. And we can find the noise margins. We found already that VOH is VDD and VOL is 0. So we found everything about this curve. We'll stop this video here and we'll see you in the next video, inshallah.